kind of copying this chart just a little bit to start off today's lesson. Bless you. In the second example here, what we have is an example of AC grouping. You know that, and I kind of said this before, when I teach you things in like a little step-by-step approach, I teach you how to do a problem. It seems very, digestible. It's kind of easy to understand the process, not too bad. What makes factoring hard is that when you start to mix up all of the different types of methods, things get cloudy. So before we actually do a method, I have to tell you why we're doing it. And to tell you why we're doing this method for this problem involves us sort of having a discussion about why the other methods don't work. So let's take a look at 6x squared plus 17x plus 5 to start. Can I take out a greatest common factor in this problem? Do 6, 17, and 5 have any numbers in common? You're shaking your head. No, yeah, there's no GCF, so that method out the window. Then I'm like, okay, well, let's try the square root method. That was a method that we talked about a couple days ago. Would the square root method work nicely on 6x squared or 5? Those are irrational numbers. That's not going to work out. So the square root method doesn't work. Lastly, I can't use the method I just showed you 2 seconds ago, because if I look at that 5 at the end, there are no two numbers that multiply to give me 5 that could possibly add to 17 in the middle. So that method also does not work, which means I have to pull in this factor of a somehow. And so this is my visual cue, since none of the other methods work, to use AC grouping. It is kind of like that. It is like your last resort. You want to avoid it because it is the longest method we have for factoring. I'm trying to teach you to be efficient. So you want to avoid doing the longest method possible at all costs. Nonetheless, it does work. So here's how it goes. First step gets its name gets its, how am I trying to say this here? The name of this method, AC grouping, kind of helps us figure out step 1. We have to do A times C. So A times C in this problem, if A is 6 and C is 5, the product of 6 and 5 indeed gives me 30. Then I have to think to myself, well, what are the numbers that multiply to give me 30 that add to 17? That's that middle term. True story, 15 times 2 multiplies to give you 30, but the sum of 15 and 2 is 17. And then I attach x's to each of those. The idea in doing this is because I'm going to take my 3-term expression and turn it into 4 terms so that I can group it into 2 and 2. So I'm going to take my 3-term expression, turn it into 4 terms. I have 6x squared. Notice I brought down my 15x and my 2x plus 5. Does everybody see that? Remember, rules for taking notes. I graded your notebook quizzes. What goes on the smartboard has to go in your notes. All of it. And if you don't understand it, you don't write it down. That's a waste of your time. Any questions so far? Okay, then you see this green squiggle? That's me grouping. All I did was I grouped my first 2 terms together and my last 2 terms together. In doing so, I can do the GCF method. So I took out a GCF out of 16x squared and 15x. 6x squared and 15x have 3 and x in common. So I pulled out my 3x, and 2x plus 5 is what's left over. And then 2x plus 5, that doesn't have any GCF, so I pulled out a 1. Well, because at least they have 1 in common. And then brought down my 2x plus 5. Do you see what I highlighted in green right there? They're identical. That has to happen. So I have an identical set of parentheses, which now behaves much like a greatest common factor again. 2x plus 5 is now a common factor in 2 larger terms. So I do the GCF method again. Bring down my 2x plus 5, and do you see how I just crossed them off? And then I wrote down what I had left over. 3x plus 1 is what you have left over. What's up, John? Multiplication is commutative. Correct. Step 4, I check it with FOIL. So I did that, and I got the original problem back out, so I'm a happy girl. That next example, turn the page, is all yours. Let's see how this goes, shall we? I just wanted to show you your answer to example 3. So I took a times c, got negative 12. Factors of negative 12 that add to 1 are 4 and negative 3. You attach x to those, rewrite what was 3 terms as 4 terms. So I turned, my trinomial in the original problem into something that had 4 terms. So I just took a moment to rewrite the problem using my factors of AC that added to B. I then did the Gcf method on the front pair of terms and then the back pair of terms. I noticed that I got a set of parentheses to repeat, which is x plus 2. So I brought that down, and then I had 2x minus 3 as a remaining factor. Looked pretty good as I walked around. I'm pleased. So that takes us to these, which I'd like you to try. Please keep in mind, little disclaimer, we always try a certain method first. Do you remember what we always try first? Very good, Gcf method. So keep an eye out. If you could take out a Gcf, you should. So I'll go ahead and give you a minute to do those. So I wanted to take a moment to show you your answers. You can take a look at those. You guys did a nice job. Really well done. Does anybody have any questions about these? Look at them carefully, especially with part C. That's the one I saw a couple of mishaps on. Part C, a couple people forgot to take out the greatest common factor first, so please make sure you do that. That's fine. Okay. We still good? Alrighty, next up. So our last method for factoring, and then tomorrow's a review day, and Friday's your quiz. The last method we have is really easy to spot when to use. Okay, long story short, this method is called factoring by grouping, and here's when you use it. You factor by grouping when there's 4 terms. No Gcf exists in between any of them, right? So, well, for the initial part. If you have 4 terms with no Gcf in the 4 of them, you have to factor by grouping. So if you take a look at this example right here, x cubed plus 7x squared plus 2x plus 14, that's 4 terms. 1, 2, 3, 4. And there isn't a greatest common factor in between them. I can't take out a 7, I can't take out a 2, I can't take out an x, there's no Gcf. So the recommended method for factoring a problem of this nature is grouping. We actually already did grouping today because we did AC grouping. Well, here's how regular grouping goes. All you're going to do is group the first 2 terms together and the last 2 terms together. I usually do that by putting a little squiggle or a wall or a line right down the middle of my problem. Do you see how I've grouped the polynomial evenly? I have the first 2 terms and the last 2 terms. Now what I'm going to go ahead and do is take a Gcf out of the front binomial. So do you see how I have x cubed plus 7x squared? There's a Gcf hiding in there. Do you see it? Good, John? Yeah, x squared is hiding in there. What's left over, John? I take a look at the back binomial. I see a common factor. What do you think, Tammy? Yeah. What's left over was the x plus 7. Do you see what happened? See that parentheses there? It's there. And it repeats over here. We get what's called a common binomial factor. That has to happen in order for this method to work. If it doesn't happen, try rearranging your problem a little bit. If you rearrange the problem, sometimes when you regroup it, you get that common binomial factor to sort of come out in the wash a little bit. But do you see how I got that x plus 7? That's what we call our common binomial factor. it essentially acts like another greatest common factor in the larger polynomial. So I can factor out the x plus 7 and then just bring down what I have left over. X squared and a positive 2 is what I had left over there, so I brought those down. And that's my answer. If I FOIL it, I get that original 4-term polynomial back out. X times x squared is x to the 3rd. Outers is 2x, inners is 7x squared, and my last is 14. That's my original problem, so it works. Okay, questions about the steps? Okay, I wanted to do one more with you, just make it a little weirder looking. So you'll see in this last example for me today, I have a mix of different letters, x's and y's, and then I also have minus signs in this problem. So the problem looks different, but the algorithm, aka the step-by-step process for solving a problem, is the same. So what I see here is I have 4 terms. There's the first term, second term, third term, and fourth term. I have 4 terms with no GCF. That is my visual cue to let me know that I should factor by grouping. I'm going to group the first 2 terms together and the last 2 terms together, but be careful. If you're a person who uses just a line to separate the 2 like I do, you got to be careful how you draw your line, right? Be very careful. If I draw this line in the wrong spot, I'm going to turn my minus into a plus, so watch out for that. You don't want to go changing signs or anything about the original problem when you go to group. So now that I have my line in there, I'm going to go ahead and take a greatest common factor out of the front 2 terms and then out of the back 2 terms. So I see that the front 2 terms have an x in common, and that would leave me 3x plus y left over. And then these back 2 terms have a factor of -4 in common. So if I factor out a -4, -4 times 3x gets me -12x, and then -4 times positive y gets me -4y. And the magic happened again. I have what I call the common binomial factor that now exists as the greatest common factor for my larger polynomial. So essentially I could take that common binomial factor out, 3x plus y, and then I just write down what I have left over, x minus 4. There it is. If I FOILed that, I would get the original polynomial back out. For students who struggle to see why I only write the common binomial factor 1 time, do you see how I only wrote 3x plus y 1 time as my answer? I ask you to take a little bit of a different take on the distributive property. You could think of the distributive property in this way. Do you see this 3x plus y that's outside of my set of parentheses? This being my bigger set of parentheses. I can actually distribute this whole set of parentheses, 3x plus y to x. That gets me this right here. And then I could also distribute this 3x plus y to the -4, and that gets me that right there. So I'm actually just distributing when I FOIL. You could think of it that way. So that's why I only write the 3x plus y 1 time. Questions about that? Alrighty, so you get to try a nice set of independent practice there. So I'd like you to spend some time taking a look at that. Don't forget, when it does say check, you should check it with some FOIL. After we're done with this practice, I'll go ahead and show you some answers. And then we're going to, I'll field a couple of questions from last night's homework. The assignment from last night, hold on to it for me. Just add on tonight's assignment. Bring those 2 assignments with you to class tomorrow. To talk about both of them would be a nice way to start off our review day tomorrow. So tomorrow is our review day for our quiz, and then Friday is our quiz. While you folks are working on this, I got to ask, is anybody not going to be here tomorrow? Because I'm going to go ahead and take some time to get you your makeup work and stuff like that. You may have any questions on these. Okay, let me scroll down a little bit so you can check the last couple. It says bring your graphing calculators tomorrow. We'll need them on Monday. You can have them with you tomorrow, and you can have them with you on Friday for your quiz, of course, but we are definitely going to need them on Monday, so just make sure they come with you for the next set of notes. The quiz is on all of our methods for factoring, Ben, yeah. So tomorrow's our warm-up. We're going to go through a big run-through of all of the methods that we've talked about over the past couple of days. And then we'll do some board work for practice, and then you'll get some practice for homework. What's up, Eddie? My blue line is in the way here. Oh, I can't tell. Is that a plus or a minus? It's a minus? Oh, it's a plus? Yeah, I just want to make sure. So this should be a plus. So that should be a plus, yes. Thank you, Eddie. Any other questions? Comments, concerns? You're good? All right, nice job. So you do have some homework tonight on top of that. You had bookwork last night, and then, oh, sorry, tonight's assignment is, page 39, you had 47 to 52. 57 to 66 and 71 to 73. I like those problems because it's a nice mixed review. Gets us off to a nice start tomorrow. So tomorrow when we come to class, I'm going to go over 2 nights worth of work. So 39, you had 37 to 46, 53 to 56, and then I'll go over 47 to 52, 57 to 66, 71 to 73. We have a flow chart to take care of tomorrow. You're going to do some board work. You're going to do a factoring review packet. I'm also going to try to pass back your Chapter 1 assessments. If you're curious as to when you're getting your test back, Nicolette's finishing hers up. So yeah, I should have them all in, so I should be able to get them back to you tomorrow. And then that'll get us in good shape for Friday's quiz. If there's any thing that I don't finish tomorrow, like whether it be passing back your tests or going over homework or anything like that, checking off homework, I'll take care of that as my housekeeping stuff on Friday. And then Friday you'll have your quiz. You have a little bit of homework to start on the next section in the notes on your own, but other than that, that'll finish up the week. Questions about that? In good shape? All right.